Hey physics fans, today we're talking about TP4-36. Now, when you first read this problem, you have to think to yourself, what are some clues to help me solve this problem? Well, they talk about distance or horizontal displacement, they talk about velocity, and they talk about height. They talk about some projectile leaving an airplane and landing on the ground. That sounds like projectile motion. So, 2D projectile motion is the type of problem we're going to solve. What do they ask us to do? They ask us to find total horizontal displacement. Well, what's a good equation to find total horizontal displacement? Well, I have this equation here that sets us up perfectly to solve for that total horizontal displacement. And the only variables I need to find from this equation are the initial velocity and time. Next step, I have to draw the picture. When I draw my picture, I draw the aircraft flying with velocity of 138.39 meters per second. That is a conversion of the 500 kilometers per hour they give you in the book. Now, the crate is dropped from the airplane. Well, as the crate is dropped from the airplane, it has the same initial velocity in the x direction as the airplane itself. Remember that. It has the same velocity in the x direction, and the velocity in the y direction for that crate initially is 0. Next step, we got to take our givens and fill out the kinematics table. This kinematics table will be very helpful to you in solving problems in Physics 205. So what I do, I set up the x direction, I set up the y direction, and then I put time on the bottom. And if you notice, the time is not solely under the x direction, it's not solely under the y direction, because time is the link between the x direction and the y direction. It is the link between the two. So let's put our givens out. Our initial position, I set my reference so that the initial point is at 0. Total horizontal displacement, that's what I'm solving for. The initial velocity, we talked about that. That is 138.39 meters per second. And the acceleration in the x direction is 0 because the acceleration in 2D kinematics or projectile motion is always pointed downwards. And as you can see from my reference frame, since acceleration is pointed downwards, it is negative. Continuing to talk about the y direction, our initial position is 800 meters, and I designated that to help me solve the problem. If that is my initial position, then I set my final position at 0. My initial velocity in the y direction, remember we talked about, is 0. And the acceleration due to gravity is in the negative direction, indicated by that negative sign. So, next thing, we got to go to assumptions. I have to neglect air resistance. If I don't neglect air resistance, then acceleration is not constant, and I cannot use my kinematics equations. Now going on to solve the problem. So, I have to start in the y direction. Why? Because I don't have time, I have initial velocity in the x direction, and I still need to find my distance in the x equation. So, setting up with my initial conditions, I get that time is equal to the square root of 2 times the initial position divided by the acceleration due to gravity. I take that equation, I label it equation 1. I apply the x equation that I started out with to get x is equal to vx naught times t, because remember acceleration in the x direction is 0, and I throw the first equation into the second equation to get our final equation, which is an algebraic solution to our problem. When I put the variables that I was given into that equation, I get that the final position is 2,000 meters. Well, let's check that. 2,000 meters, units, those are good. We're talking about displacement. Sig figs, the most amount of sig figs is 1. Therefore, I'm going to report that as 1 sig fig. Does this make sense? It does. Because my initial velocity is 138 meters per second. I'm only accelerated 9.8 meters per second squared, and I'm at a height of 800 meters. So I'm not in the millions as far as my distance is concerned. I'm not in the hundreds of thousands. I'm only at 2,000. That concludes our video on TP 4-46. See you next time. To the window, to the wall.